if the average rate of change equals a certain number, then the instantaneous rate of change will also equal that same number somewhere in between A and B. So if I can show that the slope between 2 points is 7, that means that the derivative of the function would also equal 7 somewhere at some magic number between A and B. So a lot of the mean value theorem problems are about proving or showing that f prime of x equals some special value. A lot of times that's what we're trying to get. We're trying to show that the derivative will equal some value. And the way I prove that is I say, well, look, the regular slope, the slope between these 2 points would equal that magic number. Therefore, the tangent line slope, the derivative value, has to be that number too, somewhere. At least once, maybe multiple times. I want to make sure I say that because if the problem doesn't explicitly say the words mean value theorem, we still want to be able to pick up on the idea that that's what we should be thinking. Okay? If it doesn't explicitly say that, we may not pick up on that if I don't understand what the mean value theorem is good for. So the mean value theorem is really, really good for proving that I can get my derivative to equal something special. Now, all of that being said, the IPUP problem here on the very back page is about proving or establishing how many times, the smallest number of times, we can get a prime of t equal to 0. And this function, the name of our function is a. So basically, okay, if I want to think about this as how mean value theorem will help me solve this problem, okay, if that was supposed to be an a, not a, if a of x2 minus a of x1 over x2 minus x1 is equal to 0, if the slope between 2 points is 0, then a prime would also have to equal 0 between x1 and x2. Do you understand what I'm trying to think? I'm trying to figure out, okay, how many times, what's the smallest number of times? And that's important, not what's how many is there, but what would be the smallest possibility? What's the smallest amount of times I can get this to happen? Because if I can get this to happen, if I can get the slope between 2 points to equal 0, then at least one time between them, the derivative would have to equal 0. If the average rate of change has to be 0, then the instantaneous rate of change has to be 0. This is mean value theorem. What other theorem does this go by because it's the derivative equal to 0? What's the other name for this? Rolls. Rolls is the special case. Rolls is just the special case if you're doing mean value theorem with the derivative equaling 0. Okay. So, we got to be careful that we don't overlap intervals. So the best thing to do on this table is probably, I don't know, I kind of started looking at it going from like left to right. And my first value is 150. Here's the fun question. it goes from 150 to 185, and then from 185 to 135. Now, I don't know how many times it jumps up and down between 0 and 1 and 1 and 2. It could be a lot. If I think about this, the easiest possible scenario is it goes directly from 150 to 185, and then from 185 to 135, which means somewhere in here, I must hit 150. Why is that true? What theorem is that? That's, say it again because I just didn't hear you. That's intermediate value theorem, yeah. So if I have a continuous function that goes from 150 at 0 to 185 at 1 to 135 at 2, I know it's going to hit 150 again. And so from this 150 to this 150, that's an average rate of change of 0. That's an interval where I'm going to get a instantaneous rate of change of 0 at least once. I'm not saying it only happens once. It could happen 70 times. It could just, I don't care. I'm looking for the least amount of times it can happen. So if it's as well behaved, if it goes right to 185 and then right down to 135, I can establish at least one pair of points, 150 to 150, that I'm getting an average rate of change of 0. All right, from 150, I'm going down to 135, down to 120, down to 75. Let's just pretend we're going the simplest path possible. So no ups and downs, from 150 to 135 to 120 to 75 to 75. Bam, there's a second time. Average rate of change is 0. So that means, this is my instantaneous rate of change. Every average rate of change equal to 0 means I got an instantaneous rate of change equals 0. And remember, minimum amount of times. From 75, let's assume basic behavior. 75 up to 100, up to 120, down to 60. So whether you want to think about it from starting from the 75, or if you want to start about it thinking from the 100, basically if we take over right here, from 75 to 100 to 120 to 60, I'm going to have to hit that 75 again. So that's a third scenario for an average rate of change of 0. That's a third possibility for instantaneous rate of 0. It's going to happen a minimum of 3 times. This is a tricky problem because it not only is it a mean value theorem, Rolle's theorem problem, it's an IVT problem as well. You have to understand that you're going to potentially get these other values. Yes, sir.
What about the 120, where it's a tree in 120, and it begins decreasing down 75, 75, 100, and goes back up to 120?
Okay, so here's the thing. The 120s, that interval, we're already kind of, if we have an average rate of change of 0, that means I'm going to have an instantaneous rate of change of 0 a minimum of 1 time in the interval, but it could be more. You can use the 120s. The 120s aren't a problem. It's just the fact that I'm kind of already using those X numbers because I'm going from the whatever this would be to the 5, so that my next interval would start here. So does that make sense? I mean, you can do this a lot. That's one other reason this problem is tough. 150 to 150 is one way to do it. If you count the 120 to 120, the problem is you kind of miss, let's see. Yeah, you have to, that's kind of within the same interval. So that would actually be a fourth one because it kind of overlaps those intervals. And because it's looking for the smallest number of times, that's why we're going with 3.
So it can't overlap.
They can't overlap. Right, because it's a fewest number of times. So no overlapping. Okay. All right. That's not an easy question for sure. Mostly because of that, the non-overlapping part. Okay. Let's back up to this question. This is an intermediate value theorem review question. Okay. Intermediate value theorem, if we're trying to kind of boil things down into their basic sort of what are they for, intermediate value theorem is where we're trying to prove that f of x has to equal some number. And the way we prove that f of x is going to equal a certain number is we can say, well, f of x equals, f of a equals 5 and f of b equals 10. So somewhere, and if we want to get a 7, it's like, well, we're going to have to get a 7 because we can't get a 5 and then get a 10 without hitting 7 between them. Intermediate value theorem about proving that somewhere between an interval, we're going to get a certain function value. Mean value theorem, proving we're going to get a certain derivative value. Rolle's theorem, proving we're going to get a certain derivative value, specifically f prime. So I want to prove that f of x is going to equal pi, has to equal pi somewhere from 0 to 2. Okay. And we're going to make a little note here. We're going to accept, we're going to add this as a given so we don't have to have this conversation. We're going to accept that f of x, big F of x, is continuous. Okay. So that means that we can use the intermediate value theorem. Intermediate value theorem, we need continuity. For mean value theorem, and Rolle's theorem, we need continuity and differentiability. Okay. So I'm hoping that what I'll get when I get f of 0 and what I get for f of 2 are going to hopefully be on either side, one smaller and one larger than pi. Because if I can get that, if I can say f of 0 is something less than pi and f of 2 is something bigger than pi, then that means I'm going to have to be able to get f of x equal pi, somewhere between 0 and 2. Capital F function is defined like that. Oh, we love that. We love functions defined as integrals. They're awesome. So the capital F function of 0 means we're going to do the integral from -1 to 0, because that's the x, of f of t dt. And this is the little f graph. So in one word, how are we going to calculate that integral? We're going to need to do, how are we going to calculate the value of that integral? It's not the only way, but it's the more expected way when you're given a graph. This is an area question, yes. This is an area question. when you don't have a function definition, then it's probably not a fundamental theorem question. It's not an antiderivative question. It's an area question. Integrals are areas. So we'll need to think about, we want the area under little f of t graph from x equals -1 to x equals 0. Go ahead and calculate that, and then calculate the value of f of 2, big F of 2. While you're doing that, I am going to make sure I've got attendance recorded. If you're trying to find the value for an integral and you're like, oh crap, I don't have a function, then that's probably means you're not supposed to be using antiderivatives in FTC. If it's not an antiderivative, it's probably an area. That's pretty slick because they're supposed to start with A. All right, so Jason checked out. 8, 9, 10, 11. Oh, where did we do? 16, 17, 18, 19, 22. That's over. Oh, everybody else is here. See, that's super easy when everybody else is here. Makes it so easy. Do, 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 do. Okay. So remember, it's above the x-axis. So from -1 to 0 is that little triangle. And then from -1 to 2. And if you're like, why is she starting at -1? Because that's where the integral tells me to start. It says f of x is the integral from -1 to x. So from -1 to 2 is this guy, Mr. Big Red Triangle. So like a half for the little guy. Okay. And nine halves for the big guy. Okay. What's pi approximately? 3.14. So this is definitely less than 3. This is definitely bigger than 3, right? 9 halves, 4.5, bigger than 3. So here's what we write. F of 0, which is a half, is less than pi, which is less than 9 halves, which is big F of 2. So what did I get for each of my evaluations? I got a half, I got 9 halves, and they're on either side of pi, and I got to make sure my inequality is right, that the alligators are eating the bigger numbers. So 1/2 is the little guy, 9 halves is the big guy. So 1/2 is less than pi, less than 9 halves. So that means f of x equals pi on the interval 0 to 2 because of the intermediate value theorem. Intermediate value theorem, you're trying to make the function equal something. Mean value theorem and or Rolle's theorem, Rolle's specifically when you want 0, Rolle's theorem, mean value theorem, when you're trying to make the derivative of a function equal something. And most of the time, you're showing that your derivative will equal that number because an average rate of change has to equal that number. All right, I want you to do problem 2. We may have done that problem. I don't know, it may have been the same one. And we did so problem 2 has 2 parts. It's got a big old table. We love tables. It's got h of x defined as f of g of x minus 6. Part A, you're going to prove to me that h of r is going to equal -5, somewhere between 1 and 3. And problem B, you're going to prove to me that h prime of r has to equal -5, somewhere between 1 and 3. And I will help you with the thinking. A is an IVT, B is an MVT. I wonder where I put those papers. While you're doing that, I'll look for those papers. Oh, homework. Oh, there. Oh, no, that's probably the grades. Okay. This is the homework. What did I do with that? This is not the homework. I may not do this today. Here. Where did that other sheet of paper go? Russell, 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 Russell. You showed it. It's your birthday. I got a headache like it's my birthday. There it is. All right. There it is. Oh, no, that's the note. Okay, that's what I was looking for. You are what I was looking for, Mr. Paper. Here you are. I meant to give you to Jason, and I didn't, but that's okay. All right. Okay. H of 1 is f of g of 1 minus 6. H 3 is f of g of 3 minus 6. the mean value theorem problem on this is actually a lot easier than the intermediate value theorem problem. But unfortunately, if you mess up the answers for h of 1 and h of 3, you're kind of doomed. You won't be able to do the mean value theorem. It won't work well. Okay. All right, so let's see if we're cool on this. So h of 1 is f of 2 minus 6, which is 9 minus 6, which is 3. So the first thing we've got to make sure we can do is understand, okay, first of all, given differentiable, therefore continuous, doesn't even look like the word continuous. Let me try that word again. So we're differentiable, therefore we're continuous, therefore IVT and MVT will be great. Okay, I can do IVT and I can do MVT because I have a differentiable function. Everything's differentiable, so everything's continuous. So I know intermediate value theorem, mean value theorem, all good. The continuity is all I need for intermediate value theorem. I need both the continuity and differentiability for mean value theorem. It's so, this is what they do a lot of the time. They'll throw the different, you say, hey, it's differentiable. If you get differentiable, you get continuous with it. Buy one, get one free. So you get all the theorems. Mean value theorem and intermediate value theorem. Remember, Rolle's special case of mean value theorem. All right, so I got to find h of 1 and h of 3. And I'm hoping that these two numbers are on either side of -5. So h of 1, f of g of 1 minus 6. Composition of functions. Start on the inside. G of 1 is 2. That's where my 2 comes from there. F of 2 is 9. 9 minus 6. H of 1 comes out to be 3. Okay. H of 3 would be F of G of 3. G of 3 is 4. So F of 4 minus 6. F of 4 is -1 minus 6. Which is -7. If it's telling you to explain why this has to be true, that means it's true. So that means if I had done this and I got numbers, like if I had gotten 3 and -1, I must be wrong. Because I'm supposed to get something on either side of -5. So h of 1, which is 3, is less than -5. This is another option. You don't have to write one big inequality. You can do them independently. So, okay, my h of 1, where I got 3, is less than -5. My h of 3, which is -7, is, oh, that's backwards. Don't do that because that's backwards. Alligator has to eat the bigger number. Is greater than -5, is less than -5. So I have numbers on both sides of -5. So h of r has to equal -5 for, and this is the important part, sometimes you don't say this. H of r is going to equal -5 where? For r in the interval 1 to 3. Okay. All right. Questions on part A? So the average rate of change of H, the average rate of change of H on the interval 1 to 3 equal to -5 is what I want to show. If I can show that's true, then mean value theorem says, hey, if you get the average rate of change to be that number, your instantaneous rate of change is going to be that number too. Your derivative has to be that number. All right. So how do I calculate the average rate of change of H on the interval from 1 to 3? What is that calculation? The average rate of change of H between those two numbers. What do I have to do? It's an H. It doesn't matter. It could be an F. It could be any letter. How do you do an algebra 1 slope? How do you do an average rate of change? So how about H of 1 minus H of 3 over what? If I do H of 1 minus H of 3, I've got to do right? Woo! Okay. Average rate of change. Average rate of change is just an algebra calculation of slope. Y minus y, x minus x. So the y for an x of 1 minus the y for an x of 3 over 1 minus 3. And I'm praying to God it comes out to be -5. It should. Because then I can say, oh, guess what? That means the derivative has to be -5 also, somewhere between those numbers. All right, so let's check it out. H of 1 was 3. H of 3 was -7. See, part B, you don't have to look at the table at all. You've already done all the work on part A. You just need to use those numbers in a different way. You're still using the H of 1 and H of 3 numbers, but you're using them to calculate a slope between x equals 1 and x equals 3. So, yay. I got -5. Therefore, H prime of C has to equal -5 for C in the interval 1 to 3 because of mean value theorem. If you're not sure if it's mean value theorem or Rolle's theorem, say mean value. Mean value theorem is never wrong. It's only Rolle's if you were trying to prove the derivative was 0. So if you say Rolle's and you weren't doing a 0, you're wrong. If you say mean value, you're right no matter what, if it's a derivative problem. Okay? So if you're not sure, they give credit for mean value. Even if Rolle's is a more specific theorem, mean value is fine. So, when we get to the test for this unit, which is 2 weeks from yesterday, right? It's on the 28th. You're going to have mean value theorem questions and potentially intermediate value theorem questions. I mean, I'm looking at this. Let this be a function with this, given this information, find the C guaranteed by the mean value theorem. So that's one kind of mean value theorem question that we talked about. That's basically the question that says, hey, do the mean value theorem, guys. Take that, figure out where the mean value theorem, the magic C number will show up. Figure out where the average rate of change is equal to the instantaneous rate of change. Okay, that's on here. On the old test, it was number 10. And then, oh, there we go. Yep. Show, show that there will be a time where S prime equals this on between when, and for S prime of t equals this value when t is between this value, these values. That's an intermediate, or excuse me, that's a mean value theorem question as well. Okay, I don't know that we have an intermediate value theorem question on here. We're also just working on editing, but there's definitely two mean value theorem questions. One that specifically states, hey, use the mean value theorem, and another one that's not explicit, but is a mean value theorem question because you're trying to prove that the derivative does something special. Okay. All right, any questions? Hopefully you've also been doing some work with your implicit derivatives. The next 2 lessons, which are the last 2 lessons in the unit, are going to rely on us being able to do some implicit derivatives. These are problems under an umbrella called related rates. Basically how the rate of change of one variable affects the rate of change of another variable when the 2 variables have a relationship. Right? So 2 variables that are related, how does the rate of change in one affect the rate of change of another? We're going to do that on geometry-based, one type of geometry problem, so circles and cones and rectangular tanks and cylinders and right triangles and things like that. And then we're also going to do that relating to trig, how changing sides in a right triangle create the rate of change of the angle and vice versa. It's going to take us a couple classes to go through it. We're going to start a little bit today. We'll do the rest of the first part next class, and then we'll do the trig part. Okay. We'll see how it goes. But just a reminder, kind of our plan going forward, a little bit different on our schedule. Make sure you've got this on your calendar that we are testing on the 28th. Is our Unit 5 test. And in addition to that, at that point, we would be doing a Unit 5 homework check. And so far in Unit 5, you have worksheets from lessons 24 and 25 and 26. And then textbook work on lesson 27, and I'm about to put in your hand a worksheet for lesson 28. Okay. Take a look at this and see if there's anything I want to talk about before we move forward. One of these. is a tough question. I'd say I'm just kind of scanning this assignment. Number 1 should be pretty doable. Number 2, you are gonna need to use your calculator. Tell you what, let's do that one. Let's do number 2. So let's take a look at that, because I think that I don't know where our calculator skills are. So let's grab our calculators and let's see what we can do with that problem. Okay. Basically, the calculator comes into play on the AP exam 3 different ways. Number 1 is you can find derivative values. Number 2, you can find integral values. And number 3, you can solve equations. Okay. Integral values and derivative values are built-in functions. Typically, equation solving is often about using a graph, using multiple graphs and looking at graph intersections. That's the skill I'm the most concerned about with you guys. I'm assuming by now, and we've talked about it a couple times, you're comfortable with or aware of under the math function. We've definitely talked about math 9 being where we can calculate an integral value. So if we have a calculator and we're asked to calculate a definite integral, that is just a typing question. Same kind of thing, if we're asked for a derivative value, math 8, the math menu in number 8 will do that. It will calculate the value of a derivative at any given number. So if we have the derivative with respect to x of x, x to the 4th power at x equals 2, it doesn't show you the derivative, it just takes the derivative and then evaluates it. It actually is doing it geometrically, so sometimes it looks like it's not an exact answer. It is in fact an exact answer, but your calculator is using a geometric process to do that, and so you're going to get these little bits of error. So we know the derivative of x to the 4th is 4x cubed, and if we look at 4x cubed and we plug in x equals 2, 4 times 2 cubed is 32. Okay. So calculating a value for a derivative, calculating a value for an integral, built-in functions for that. Solving an equation or coming up with solutions for an equation where 2 things are equal to each other, that's going to be a graph tool. So let's take a look at problem number 2. Since this is when it says calculator allowed, that typically means it was calculator necessary. And it says there are no, it doesn't say 2. There are values, it implies there are multiple values of C that satisfy the mean value theorem for this function. F of x equals 2 cosine of x minus 4 cosine 2x on the interval 0 pi. It asks us to find the sum of those 2 numbers, or sum of those numbers, however many. It may be 2, it may be more than 2. But whatever the satisfying numbers are, mean value theorem. To satisfy the mean value theorem, that would mean that we are able to make the average rate of change equal the instantaneous rate of change, or essentially figure out where that happens. Finding C. Okay. So how do we start? Just so we're clear what we have to do, we have to make the average rate of change. We have to figure out where the average rate of change is equal to the instantaneous rate of change. So how am I going to find the average rate of change for f on the interval 0 to pi? Ian, how do we do it? Right, so tell me exactly what calculation I'm going to do. Okay, we're going to do f of 0, and how about f of pi? And what am I going to divide that by? Okay, because that is how I'm going to calculate the average rate of change of f on the interval 0 to pi. I'm going to do f of 0 minus f of pi over 0 minus pi. And the nice thing is, if you don't know your unit circle, at least in this time, you've got Savior, because you've got your calculator. As long as you're in radians, not degrees, we're always in radians in calculus. Right? So if we need to, we can use our calculator to help us with this. This is actually not why we have the calculator, because this is doable without your calculator. So let's see, f of 0 would be 2 cosine 0 minus 4 cosine 2 times 0. So 2 minus 4, it's negative 2, because cosine of 0 is 1. F of pi, 2 cosine pi minus 4 cosine 2 pi. You can type it in if you need to. Cosine pi. I'm always thinking about the cosine graph. Negative 6. You guys checking me? Am I good? Nobody's just watching me. We're just watching. All right, let's see. Cosine. Never mind. All right, that's negative 2. Just making sure I'm not doing anything dumb. You gotta watch, if you're gonna use your calculator, you gotta close those parentheses when you take the cosine of something. So 2 cosine pi, close your parentheses, 4 minus 4 cosine 2 pi. Yeah, all right. So negative 2 minus negative 6 over 0 minus pi is 4 over negative pi. I'm not going to worry about a decimal approximation for that. I could get one if I wanted it, but I'm just going to leave it like that. All right. 4 over negative pi. Now, why did I do that? What am I going to use that for? That's the average rate of change. What do I have to make equal to that? The IROC, the instantaneous rate of change, which is secretly the instantaneous rate of change is nothing but the derivative. It's the derivative. So I want to make that the derivative of that function. I want to figure out where it's going to equal that cuckoo crazy number. That's why I have the calculator, because that number is crazy. Thank goodness I have a calculator, because there is no way I'm going to be able to figure out where the derivative is equal to that algebraically. It's not at a nice number. Here's the next trick on this problem, though. I got to write the derivative of this. Okay. I got to come up with where the derivative and the way I'm going to do that is I'm actually going to graph y equals f prime of x, and I'm going to graph y equals negative 4 over pi, and I'm going to find all the intersections between those two numbers, because that's the limitation. I want the instantaneous rate of change equaling the average rate of change. I want to know where that happens. And just to be fun, I got to add them together. So there must be more than one time. That's how I solve equations with my graphing calculator. I don't really use the equation solver. There's ways to do it with that. I knew them once, but that's not the intent. If we have a calculator and we're supposed to be solving an equation, with a graphing calculator, we are intended to be graphing both equations, or graphing what's the function that's on both sides of the equal sign, and looking for any intersections. All right. Let's go back to this function. Oops, there we go. Let's grab him. Sine, cosine, negative cosine, sine. I write it down every time. We're taking the derivative. That means we're going to go down this list. So that means from cosine, we're going to go to negative sine. So f prime is going to be negative 2 sine x a negative cosine is going to become a positive sine, so plus 4 sine 2x times 2. Where'd my extra 2 come from? Right here, little chain rule. I forget that, I'm done. So negative 2 sine x plus 8 sine 2x equals negative 4 over pi. That's what I have to solve. There is no way that you're going to solve that algebraically. You're just not going to do it. They're not nice numbers. They're not unit circle values. You're not going to just be able to kind of like think about this or factor it or rewrite it or do anything with this analytically to get up a solution. That's why you have this on this problem. All right, so let's do this. And then I'm going to show you, I'm actually going to show you another trick too. All right, so y equals -4 over pi. Fine, there it is, -4 over pi. Y equals, let's see, what mode am I in? I am in radians, so that's good. Okay, so y equals -2 sine x, gotta make sure I close that, plus 8 sine 2x. Close that. Graphy graph. Now, when I graphy graph that, I'm going to get a lot of stuff. Those two things intersect a lot. Thank goodness I don't need all of them. I'm only interested in the intersections that happen between 0 and pi. So maybe I'll make that -1 a little bit smaller than 0, and maybe I'll make that 4 a little bit bigger than pi, and then did I even want that? Yeah, maybe I needed, so where is this one? Oops. That one worries me. I can see this one. I can see this one right here and right here. I think that's probably at 0. Let me do this. There's that. Yeah, okay. So that first one is a little bit beyond, a little bit on the other side of 0. So if I go 0 to pi, since none of them are on the boundary, even if I make that pi, because that's pi right there when I scaled this. And if we want to, another thing you could do here, do a little zoom 7, which will line, it'll do it as a trig scale. It's going to go back to kind of what we did before, but at least it marks it. And then if you want to change this from 0 to pi. Okay. Okay, so I got an X right here and an X right here where they cross. Look at your answer choices. Talk to me about what you're going to throw away without, use some logic here. Those are the two X values we're going to add together. Tell me what answers you can throw away. Ian, why can you throw away A? If you're adding, thank you, you're adding two positive X's together, ain't no way in hell you're getting a negative, right? So A, out the window. It's not possible. While I'm a betting person now, if I think about the scale on this, and maybe I even do a little, actually I was going to do a little tracing. Let me move all my little dooflachis out of the way here. If I try to get close to that number, I find, you know, that X is definitely more than 1. it's like 1.5. And this x is pretty close to 3. So if this is like 1.5-ish, and this one is 3-ish, B and C should go too, correct? Okay, so just on, even if we can't go any further, if we're like, I don't know how to exactly figure out what those numbers are, the only reasonable guesses are D or E. Because they're the only ones that make sense based on about what this x is and about what this x is. This x is about 1.5, and this x is about 3. So 4.5 is a good guess. So D and E are both still in the running. All right. Here comes Algebra 1. Back to smack you in the face. And unfortunately, if you did this on Desmos, I'm sorry, but we have to know how to do it on our TI for right now, still for College Board. I want it to tell me where they intersect. On Desmos, it's really nice. You just click and it shows you the intersection. On the TI, you got to make it tell you. You got to calculate. Second trace for calculate. The intersection, number 5. And it's going to default to one of your, whichever one you typed in first. So it's on my first curve. I'm going to press enter. And then it's going to go to my second curve. It shows it right there. Whichever one it's closest to, whichever intersection it's closest to, it's going to go to that one first. So I know that intersection is 1.525. 1.525, blah, 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 blah. Hopefully that'll be enough. Okay. And then I'm going to tell it to do it again. Intersection. I just got to move closer to this side, to where it crosses over here. .07. Yeah, it's E. It's going to have to be E. There's a lot of skills in that problem. There's the obvious one, which is you've got to know what mean value theorem is about. If you don't know what mean value theorem is about, you'll have no clue. Okay? And if you read a question like that on the AP exam and you're like, I have no clue even how to start, that's a good indicator that you guess and keep going. Because when you're on a timed test, if you're not sure even how to start, chances are you are not going to get it right. You have a better chance of guessing and moving on to something you have some idea how to start. So number one thing on a timed exam like the AP exam, if you don't know even how to begin the problem, if you like mean value theorem, I don't even remember what that's about, pick a letter, let it go. You might get it right, you might not, whatever. Once you get past the fact you have to know mean value theorem, and then you need to know, if you know what mean value theorem is about, you have to know what each of those things are. You need to know what an average rate of change is and an instantaneous rate of change is. And then you have to be able, the average rate of change, given the calculator, that part should be easy. The instantaneous rate of change is a little trickier. I'm going to show you a trick on that though in just a second. And then the calculator skill. That's what makes it that's what makes it hard. That's what makes it hard. It's not just like do one thing. It's do like a million things all at one time. Now, your calculator will not show you a derivative in algebraic form. However, and this takes a while to do though, you can ask it to graph a derivative. So let's say I am not sure I know how to find this derivative, but I know I really just need to see the graph of that derivative. If I do math 8 in this graphing screen and tell it to do the derivative of, and I'm going to type the original function, minus 4 cosine 2x, close it up. Thing I got to remember is out here at the end, I got to put x equals x. It's going to take a long, oh, it's not too bad. It's actually not doing it too bad. Yeah, it's pretty slow. It's graphing the derivative. So if a problem requires you to think about the graph of a derivative, your calculator can show you the graph of the derivative. It can't show you what this derivative is analytically. It can't give you the equation for the derivative, but it'll show the picture. And if you see, that's the exact picture that we had before. Okay, that is what we did find here is the derivative. That's another way you can check if you're not sure. Sometimes if you found a derivative right, graph your derivative and then tell the calculator, hey, graph me the derivative of that function, and you can see if they're actually the same function. All right. What other question? Let's do number 4 since we still have time, and I decided we're going to stick with this. Let's go ahead and talk number 4, and then the rest of these you should be able to do on your own. All right, so number 4, check it out. It's a BC question. That doesn't mean it's not also AB relevant. Let f be a polynomial function with degree greater than 2. A doesn't equal B. F of A equals f of B and is equal to 1, which must be true for at least one, mistype there, for at least one value of x between A and B. F of x equals 0, f prime of x equals 0, f double prime of x equals 0. Okay. F of A equals f of B, which equals 1. And A and B are two different numbers. Okay, that's important. A and B are different numbers, but the slope between them is 1. Okay. When I look at something like this, from this kind of given information, that makes me think maybe I'm supposed to be thinking of intermediate value theorem. And we're talking about what has to be true. So let's think about this. F of A is 1, f of B is 1, A and B are different. And it's a polynomial. So that means it's nice and smooth and continuous and no crazy stuff, no asymptotes, no sharp points, nothing weird, some kind of pretty wiggly curve that's not a parabola. Okay. Degree greater than 2. So it's like a cube or a 4th degree or 5th degree, so it's some kind of wiggly polynomial. So let's say here's A, here's B, they're different. Here's 1. F of A is 1. F of B is 1. One of my choices says it would have to absolutely be true that f of x is equal to 0 for x between A and B. What do you think? I mean, it's possible it would be, right? That would count, and that would be kind of a polynomial. But it's also possible that it wouldn't. You know, I could do that, right? That would count. So, is this guaranteed to be true? I don't think so. I don't think we have to hit a 0 because they're both 1. You know, I can get to 1 from 1 back to 1 without going through 0. Now, what about this? The derivative has to equal 0, somewhere between a and b. Well, the way I have it drawn now, it does. So if I'm thinking mean value theorem, if the average rate of change is equal to 0, then the instantaneous rate of change would have to equal 0. If f of a and f of b are both 1, that's an average rate of change of 0. That's an instantaneous rate of change of 0. So definitely 2 is a yes. So if I look at my choices, A is out, B is out. Because I need something that includes 2. Three is a concavity question. Am I going to have a potential point of inflection? Do I have to have a change in concavity? I feel like this picture right here shows that we don't have to have it. Because here, we are definitely concave down. It's kind of a little up there. I don't know. We're gonna put a pin in that. I have to go back to what the calculus argument is on 3. Mine's blank. Oh, it's not D either, though. Oh, that's awesome. Okay, so we're down to either C. Oh, I lied. Oh, it has to just be 2. See? If you don't read carefully, you can waste a lot of time. 1 was in a bunch of them. 2 works. It's just C. Perfect. Okay. I did the 2 hardest questions on your homework for you. You have the rest of them to do. Related rates next time. Fair warning, if there are senior skip days, and I'm going to put some air quotes around that, on B days, calculus is happening regardless. All right? I teach AP Calculus 8th period every 8th period from now till the AP exam. So, if you're going to choose a senior skip day, just know you're missing stuff. All right? I'm not taking breaks. If only my juniors are here, tough turkeys, okay? So just in case, it was all good yesterday because I didn't have any AP classes yesterday. It was just applied and I can be a little loosey-goosey, but I'm not loosey-goosey with you guys. AB happens every B day. Blush it. You don't feel good? Okay. Okay. All right, friends.